This is Qt 5 Design Patterns, Section 8. This section covers creational patterns, and these patterns are not specific to Qt. They're well-known patterns you can find on Google, and they go across all languages and all frameworks. This is how you create objects. We're going to talk about things like the abstract factory, which creates an instance of several families of classes, the builder, which separates object construction from its representation, the factory method, which creates an instance of several derived classes along with object pools. Think of this like thread pools or real memory-intensive classes that you want to reuse. Prototypes, which are fully initialized instance of objects to be copied or cloned, along with magic statics, which means there is one and only one class that can exist in memory. We're going to start talking about traditional design patterns. Specifically, this video is going to cover the abstract factory. So what does this do? Well, it's a creational design pattern that creates related items without specifying a concrete class. That's key, without specifying a concrete class. I want to also introduce a website we're going to refer to from time to time called sourcemaking.com. I have no affiliation with this website. It's just a really great site. So sourcemaking.com really covers a lot of what I would call the traditional patterns, from creational to structural and behavioral, and they have examples in most of the major languages. So this is a resource you can take with you to pretty much every language you go to. And once you get these patterns down, you know how they work in every language. We're going to deviate because we're going to talk about specific challenges with Qt, and we're working with C++, so drum roll. A lot of this website uses inheritance. We're going to use interfaces because interfaces are really kind of the preferred way. There's a long, exhaustive conversation as to why, but when you make an inherited object, you are basically tight coupling with that class, and it's very easy to break things. We talked about that with inheriting Qt threads. So almost always we will refer to an interface, and in case you skipped that day in C++ class, C++ has no built-in concept of an interface. You've got to kind of create it yourself. You can implement an interface, or I'm sorry, an abstract class, which contains only pure virtual functions to create the interface. Key here is contains only pure virtual functions. Now you see even in the example, the first thing is, that's not a pure virtual function. So this tends to cause a lot of arguments among C++ developers because some take the directions to an extreme. It must contain only, and because this doesn't have a pure virtual function in there, well, now it's not actually an interface. And then the argument ensues. So anyways, without any arguments, let's go ahead and make our interface. We're going to create a header file here. We're going to say iAnimal, and we're going to put this in the interfaces folder. Create that, bang, and finish. So just for the sake of time, I am going to do a bit of copy and pasting because we got a lot of this to go through. So here is our iAnimal interface. It's just a class with a public section, and it's got virtual void eat, sleep, move, and then we have our virtual deconstructor. Notice how we're implementing this. This is going to make some people mad because now it is no longer purely an interface. That's frustrating. Also, special note, in the past I've had people with Visual Studio compilers complain about this where it says =0. You have to do something different. So spoiler alert, you may have to look up your compiler's specific directions on how to implement this. 99% of the time setting it to 0 will work, but sometimes you got to do something a little bit special. When in doubt, look up the directions for your specific compiler. All right. Now we're going to go ahead and make another interface. This is called the iAnimal factory. This is our actual factory class here. And grab my notes. So this is going to include the animal interface. I can't even say it. The animal interface, and it's got a public section with create small, create medium, create large, and again, deconstructor. Notice how these are returning a pointer to the animal interface. So it doesn't matter what kind of factory we make. We could make a bird factory, a fish factory. I mean, we could actually, if we wanted to, we could make cars that eat, sleep, and move. I wouldn't want to do that, but that would be terrifying now that I think about it. We could do that if we really felt like. So the point is, an interface is just a contract between two objects, and now we can take that contract and apply it to objects. So let's go ahead and do that. First thing we're going to do here is we need to make some cats. I love making cats. So we're going to add new, make a class, and let's call this house cat. This is going to be a queue object. Next, next. Give that just a second to catch up here. And we're going to go ahead and go in here and we're going to implement that interface. Did I put that in the wrong spot? You know what? I don't like house cat there. Let's move this. Doesn't matter. I'm just going to get rid of that. I want to put this in a nice, neat little folder. That way it's easy to find. Let's go ahead and remove that. And let's go ahead and go add new. Let's try that again. And we're going to say house cat. Browse. And there we go. Cats. It was going to mess up my whole train of thought if I didn't put that into its own little subfolder here. I like organizational and structures in programs, and a lot of tutorials really don't show how to make that structure. All right, so now that we've got our house cat, we're going to implement this iAnimal interface. So we're going to grab this, paste that in there, right click, refactor, insert virtual function of base classes, and iAnimal is going to eat, sleep, and move, so we're just going to implement that. Special attention right here on the insertion options. We're going to insert into the implementation file. You can do that however you want it. And it's just going to do that for us. And I'm just going to say, the rest of this I'm going to bang out really quick. And I actually want to see when this is destroyed, so I'm going to say and let's go here and say queue info the rest of this is going to be fairly boring. Just going to paste that in. Because that's what cats do. They eat, sleep, move, and they destroy things. But anyways, so now we have a house cat. Now remember, our interface for our animal factory is we're going to create small, medium, and large. So we have a small house cat. Let's bump it up in size here. Let's go ahead and go class, and let's call this Bobcat. Could have said something like Lynx or something like that. I just want like a bigger than a house cat sort of thing. And we can actually just grab this. Rename that. And I'm going to add in our deconstructor. And let's go ahead and implement. Again, I'm just going to whip right through that, so some of this may be off the screen. Going to grab this. And let's say Bobcat. Probably a much faster way of doing this. Trying to find that fine line between going fast but not so fast where people are like, whoa, whoa, I don't understand what you just did. So now we have our Bobcat that also implements that interface. Now, last but not least, we need a large for our animal factory. So let's go ahead and create a lion. And again, I apologize. Like I said, this code is going to be fairly boring. Really focused on the creational pattern. And let's say lion. And let's go ahead and grab our implementation here. Go into the lion. So where would this design pattern really be useful? Honestly, in tons of different applications. One that really comes to mind, obviously, is a video game. So let's say you're making some kind of video game and you wanted some sort of randomized pattern here. What you could do is say, hey, we're going to spawn some cats, but I want to do it in kind of a almost random fashion, like a random generator of some kind. So let me grab some includes. We're going to have QDebug, QRandomGenerator, and we're going to include cats. And we haven't done that cat factory yet, so that's why it's giving me some sort of issue. So what we're going to do here, comment that out. But where I was going with that train of thought is, the random generator would pop up and then bang, cats would be all over. And you want to make small, mediums, and larges. So we've got our cats. Let's go ahead and add new. And we're going to say cat factory. Next. And the cat factory itself, this is where the magic really happens here. We're going to include the house cat, the bobcat, and include the lion. Also, we want to include, you guessed it, interfaces the animal factory. And this is where we're going to go ahead and implement that animal factory. And let's go in here, and I swear I hear a truck in the background that's going to drive me insane. Part of the problem with making these raw, unedited videos is you get all sorts of background noise that's really hard to filter out, so I apologize if it's picking that truck up. So now that we've implemented this animal factory, you can see it's going to return a pointer to an iAnimal interface, this guy. And this is the beauty of the factory pattern here, is now that you understand how this works, it's very, very simple to take this and apply it to just about anything. So now we can say return new house cat, return new, and we say bobcat, and then return new lion. Now, if this seems very rudimentary for all the work that we just did, you're absolutely right. So the factory is designed for if you have a lot of different class types, like we have 3 different types of cats, and we want the factory to just generate them as we need to. All right, now let's go ahead and I'm going to make a function here after I include our cat factory. There we go. So notice how we're only including the cat factory and the iAnimal interface. We're not messing around with bobcat, house cat, lion, because we want this generic interface. I shouldn't even call it a generic. This high-level interface, this contract between objects. And this is where interfaces really shine. So I'm going to say void make animals. Notice how I'm not calling it make cats. I'm saying make animals. So we can apply this to just about anything. And a little bit of copy and paste just to save a smidge of time. Boom. QList, and this is going to be a list of iAnimal pointers called animals and count. And we're going to say cat factory. And then I'm going to say for, we're just going to make a for loop here, int I equals 0. I is less than the count. And then I increment. And I'm going to, you guessed it, could have just pasted in that whole for loop. Very, very simple code. All we're doing is we're saying get a pointer to the iAnimal interface. We're going to create a random generator that's going to be bounded between 0 and 3. And then we're just going to switch saying, hey, factory, create small, create medium, create large. Very, very dead simple code. Really all we want to do is see this factory in action. So what we can do now is go down here. And let's go ahead and make this happen. So we're going to say there's our list of iAnimals. We'll say make animals. And we're going to make 25 animals. Again, this code is highly, highly simplistic. There's just a lot of drudge work that we have to do. I don't know if that's the official term. I call it drudge work. And we're going to say iAnimal, animal. And for each iAnimal in animals, then we're just going to do something with that. We're going to say eat. Now that we kind of understand how interfaces and all this stuff works together, I may in these coming videos just skip through a lot of this and have a lot of this already pre-made, so you're not sitting here watching me type all this garbage out. I just wanted to cover the basics, so if somebody doesn't understand an interface, they can refer to this specific video. All right, now that we have created a bunch of pointers, we of course need to do some cleanup. Don't really need to clear because it'll clear itself, but I just want to throw that in there so somebody doesn't say, hey, you have a bunch of dangling objects there, or dangling pointers, which we would have. So let's see this in action. That was a lot of work. All right, save and run. Everything works as expected here. So we have created a house cat, bobcats, lion, and it's fairly random. And you can see they're being destroyed as you would expect as well. Could we have put that in a queue shared pointer? Absolutely. It's just simply a design choice. So the main takeaway from this is the abstract factory creates items without specifying a concrete class. So that's why we're really using the interface, iAnimal, and in our factory, we're just defining we want to create a small, medium, or large, which we can use very, very quickly. Again, this code is not highly complex. You're really trying to understand the pattern here. And think of constructors as factories that churn out objects. That's straight out of source making. They do it a little bit different, but really what you want to understand is that you can very easily create a ton of objects, and it's just a nice simple pattern to really have in your arsenal. Okay, so we're going to talk about the builder design pattern. Now, this gets a little bit complex. So the whole point of a builder pattern is to take a complex build problem. When I say build, we're really just creating a class under the hood. But you take a complex process and make it very, very simple. And again, I'm going to reach back to sourcemaking.com. Big shout out to them. They make it super simple to understand. So really what you have is some sort of client, a director, and a builder. So for example, a restaurant, you'd have a customer as the client, the cashier is the director, and the restaurant crew actually builds the meal. And it returns back a finished product. So we're going to take a quick look at this, but there are some general rules of thumbs you should really pay attention to. Sometimes creational patterns are complementary. Builder can use one of the other patterns. And you're going to see that time and time again where these patterns kind of bleed into each other and you get a little confused over which one you're actually working on. So the builder focuses on constructing a complex object step by step. That's key right there, step by step. And builders are often a composite. Now when I say a composite, it means more than one class combined into a class. Whew. All right, now our folder structure, I've got a lot of this already set up. We've got directors, interfaces, meals, builders. So let's flip over into our project view. And I've got a fair amount of code already in here. All the includes are already set, but let's just do a super quick review. So I always favor interfaces over inheritance just because I like that contract between objects. So at the very basic, we have a meal, and we're implementing that meal down here in our burgers, and we should actually do it right there. So here's our iMeal interface, just prepare, return a list of ingredients, set the ingredients. So we've got a getter and a setter, and we can show the meal, which just prints it out, and our deconstructor. Our burger, bare bones, very, very basic, just implements the iMeal interface with prepare ingredients, set ingredients, and show, and we have an internal string list. And if we flip over to the source, it's just a lot of QInfos. I didn't want to bore you with me typing all that out. So basically all we're doing is we're showing this object's life cycle through the builder process. So understand that we're talking about a burger. And there's more than one kind of burger. There's billions of kinds of burgers. So this is the perfect example for a builder pattern. All right. We want to know when the burger was created, destroyed. We want to actually do something when we're preparing it. And we want to return a list of ingredients, set the ingredients, and actually print out every little detail of that burger. All right, not complex code. There's just a lot of what I call plumbing where you got to connect everything together. From there, we have our director. Now remember from our example, this is the cashier. All the director is going to do is return a pointer to an iMeal, in this case, a burger, using the create function. And it's going to take a builder. Now, this is where I want to slow down just a little bit here. So all the director does is say, hey, what do you want me to build? Give me a specific kind of builder. This could be a bacon cheeseburger, a veggie burger, a turkey burger. It could be a helicopter. It could be a hospital. It could be, I don't know, an infinite universe. You just hand it something that follows this iBuilder interface. In the iBuilder interface, very, very simple. We've kind of tweaked this specific to our use case if we're building a burger. So we're going to set the ingredients, prepare, cook, build, and there's our builder. So very, very similar. You see these set ingredients, prepare, cook. Let's dive in, see what it takes to actually do this. Now I've got some of these already pre-staged. So for example, if I go into directors, I have a burger director, but we haven't actually implemented that interface. So I just wanted to get a lot of the boilerplate code out of the way. All this is a basic Q object. There's absolutely nothing in there. All right, so in the spirit of saving time, a little copy and paste action. So might not actually use all of that, but we will find out. We're going to implement the iDirector interface. Now you may be wondering, if you're only going to do one director, why do you need an interface? Well, in case I want to do something else later. So the iDirector, we're going to implement the create. Remember, it takes a builder. There it is. And I want to actually do the deconstructor. Don't really need it, but I want to follow this life cycle here. Let's go ahead and flip in. And in here, super, super simple. Going to do a little copy and paste right there. So we've got our constructor, our deconstructor, and then our create. And this is what we're really focused on for this design pattern. So all the director does is say, create something using the given builder. And the builder, of course, is that interface, the iBuilder interface, which has set ingredients, prepare, cook, and it's going to build. There's our builder pattern, and then it's just a deconstructor. So going back in here, very, very simple. Just going to paste some notes. So the director is going to build a burger using this specific builder. And we're just going to say return builder build. And you see it's going to return a pointer to an iMeal interface. So we're talking about contracts. We're trying to make this as abstract and reusable as possible, but at the same time, follow the design pattern and keep it very simple to understand. All right. Looking at this, it's not super complex. So you may be asking yourself, what is the point of the director? We may want to do other things here. For example, you may want to do special processing or give them a discount or set some other properties of this builder that might not have already been preset. Save, and let's give this a good build. Just make sure we haven't goofed anything up so far. Now let's go into our builders. Because the first thing we're going to do is say, hey, director, build something. So we need some builders to actually build things. And I've got a hamburger builder, a turkey burger, and a veggie burger. Let me close some of these things out just to reduce clutter here. So again, these are just normal Q objects. All I did was create a blank class. There's absolutely nothing in them. Let's go ahead and implement our hamburger builder. So I'm going to paste in the interfaces. We're going to use the iBuilder, the iMeal, and the meals burger. Because our burger is just our generic object that we're going to return, or an iMeal. All right, lots and lots of code here that we can just play around with. Going to make a deconstructor just because I want to see that full object's lifecycle. And let's go ahead and make life super easy. We're going to say public iBuilder. And then right click and refactor, insert virtual function of base class. Let me pull this over so we can see it. And the iBuilder is going to set ingredients, prepare, cook, and build. Just click OK. It's going to put everything in there for us. Flip over here, and I'm going to save a lot of time here and just paste in the code. Now, there's nothing super snazzy about this. We did actually miss a private variable, and that's why it's goofing up on me here. So let me go back here. So it's just our ingredients list for our set ingredients. Anyways, back to the code. There's really nothing super complex here. It looks like a lot, but it's actually very simple. We have a constructor, a deconstructor, our setter, and we're going to say hamburger builder build. So this is what the director is actually going to call, and we're going to return an iMeal, in this case an instance of a burger. And all we do is we say make a new burger. The goal here is to create an object ready for use. We're going to prepare it, we're going to cook it, we're going to set the ingredients from our internal list, prepare the burger itself, and then return the burger. Now notice there's two prepares here. So prepare is actually preparing the kitchen, but we're also calling the burger prepare, not specific to the design pattern. I want you to understand that you can take this any direction you want. The whole point of the builder pattern here is to, you guessed it, create a completed object ready for use. So all the builder pattern really does is take a complex build process and make it super simple. Notice how we've got a few builders, hamburger, turkey, veggie. So let's go ahead and let's close this out. And we're going to actually, while I think about it, grab this, bang, and we're just going to implement this. I'm going to go through this fairly quickly because there's no point in wasting your time. It's literally the same process. And then our hamburger builder, where are you at? I'm going to collapse some of this just to reduce some clutter here. We can actually just grab all of this, go into our turkey burger builder. You ever want to say that really fast? Turkey burger builder. Say that like really fast. And we're just going to do some cleanup here. Just make this code actually work. Alright, so turkey burger is a little bit different because we're not going to cook a beef patty. We're going to cook a turkey patty. And then we're going to add that turkey patty. Pretty simple. So this is really the point of the builder pattern here, is you can take a generic high-level object or even an interface and do some complex build process to it, but you got to return a completed object. Let's go ahead and let's just stop blabbering and let's get this done. So let's do the veggie burger. Going to implement the iBuilder interface in the veggie burger. And I don't want this to be an exhaustive list of every possible burger out there, so we are going to stop at the veggie burger, but I'm just going to implement this super quick, just so we can see we can have different types of burgers. Uh-oh, what is this thing's problem? Definition implicitly declared. Yeah, well, guess what? We're going to go back in there. Probably could have just done it that way. Sometimes the interface, or the IDE interface, doesn't really want to be my friend. There we go. And then let's do the same for the veggie burger. Make sure we don't make the same mistake there. Right click, and let's go ahead and add that definition. We can just go in here, veggie burger, and bang. Not super hard. Once you get into a rhythm, you can really bang this out. So, same thing, cook. Well, what are we cooking? Well, we're cooking a veggie patty. So, I don't really know what a veggie patty is. Is it like cabbage or something? But anyways, let's go ahead and add that in there. And I'm going to actually spell veggie correct. I'm not even sure how you spell veggie, to be brutally honest. I wouldn't eat a veggie burger, but I'm told they're delicious. So, clean up any little issues that we may have, and let's close all that out. Make sure we save, rebuild, and just to recap here. So we have a client somewhere, which we have yet to create, which is going to be our main, who's going to talk to the director. The director is going to go in here and build a meal using a builder. The builder actually defines what happens under the hood. That's why we have a hamburger builder, a turkey burger builder, a veggie burger builder. We could have a hot dog builder, a hurricane builder, whatever we wanted. Ice cream builder. Ooh, ice cream sounds really, really good right now. Anyways, got a little sidetracked there. I could use an ice cream builder, not going to lie. All right, let's build up our client. First things first, I'm going to put in a utility function here. Get toppings is just going to return a string list of toppings that we're going to use, just kind of the standard, but this would be like taking the customer's orders. There we go. Now let's go ahead and make a test function because I want to see these objects in their full life cycle. And we're going to say now we want to make our burger director because we're a burger shop. I don't know what we would call us. We can't say Burger King or McDonald's or any of the popular fast food chains because we'll get sued, but I don't know. Brian's Burgers has a nice ring to it. So we're going to say build normal. Maybe. There we go. So we just have a function that returns a pointer to an IMail. So what we're going to do here is just say, give me a director. And because we're working with pointers, we should do a lot of the intrinsic stuff like, hey, make sure this actually is an object and things like that. We're going to do away with any of that just for the sake of time. But yes, you should do some checking. And anyways, I'm going to say hamburger builder. And builder, not set ingredients. And here we're going to call our utility function get toppings. And then we're just going to return our director. Notice we're returning the director create, and we're handing a builder over to the director. So basically what we're doing under the hood here is, whoops, I really screwed that up. There we go. Basically what we're doing is we're saying get the instructions out of the staff's guide to how to build a burger. The director's going to say, hey, build team, here's the directions, go build it. And the builder's going to go off and build it somewhere. And in case this really gives you a twitch that we're not really following suit here, we can switch it to that and then switch it to that. Point being, though, we are going to return a pointer. So let's go ahead and grab this. And we've got a few different builders, so we can just take the same pattern here and we can say build turkey. We've got our director, same thing, get the ingredients. Now, instead of a hamburger builder, we're going to do a turkey burger builder. Notice how everything's the same, except for it cannot cast into its private base class. So we screwed something up along the way here. What did we screw up? Burger director. That's a builder. We got our builder interface. Let's see what we goofed up here. Turkey burger builder. Builders cannot cast turkey burger builder into its private. What's it really saying here? Base class iBuilder. Why can't we not do that? There's always some issue, I swear. All right. Let's give it a build. I'm going to see what's really going on here. Builder is an inaccessible base. Yes. This is what's going on. In case you ever run into that, we actually did the private. If you omit that, yeah. See, if we do it like this, we're doing the private part of the iBuilder, which there's just nothing there. So we want the public part of it. There we go. Gosh, that made me just stop and go, what did I do wrong? There we go. Now we get a good build. And same thing, just so we avoid any sort of issue, make sure we're doing the public iBuilder. Sure enough, we are. Now we're going to do the veggie. See, it's when you get typing super fast, you make mistakes. Build a veggie. Still no idea how to spell veggie. I'm pretty sure it's V-G-G-I-E. And we're going to make a veggie burger builder. Point here is not so much my horrible spelling or coding mistakes, but more of the build pattern itself. We're going to take just a director, give it a builder, and then say director create, and then the builder's going to go off, build it, hand it back to the director who's going to return it back. All right, now what we can do is go into our beautiful little test function. We are actually almost done. We're going to say Q scope pointer. And here I'm going to say iMeal. Notice how we're not saying burger, we're saying iMeal. So we'd say P normal. Why is that important? Well, it's how we built this. I like working with interfaces. That way I know the contract is not going to be broken due to inheritance or some other goofiness. And then I'm going to build normal, and we're going to just give it the director. So then we're going to say P normal show, which really just prints it out. And I'm going to do the same thing. You guessed it, for the others. Our turkey and our veggie. So I can just grab build turkey. And let's call this P turkey. What a name, P turkey. And then build veggie. I'm just going to spell it like that. I'm going to actually, after this video, look it up because now it's going to bug me. All right, not super hard. Let's give this a build. Let's run it and see what it does. Sure enough, everything works. Let's go all the way to the top. So we're creating our director, creating our builder, building a burger, and then you can just follow the whole thing. So the burger is actually going to go through and we're going to say, here's our hamburger builder. And then it's printing it out. And it's got our beef patty, as we'd expect with our hamburger builder. And then the turkey burger builder is going to do the same thing. We've got our turkey patty. And then the veggie burger builder, lots of action, veggie patty. And then everything's destroyed as we would expect. So really all we're doing here with the builder pattern is we're taking a complex build process, making it simple, making it uniform, so it doesn't matter what we're trying to build. We can just say, hey director, go create something, and hand it the instructions, in this case the builder, and the builder is going to know how to do all of that detail. So it doesn't matter if you're building a hamburger, a pizza, a helicopter, a cat, a lion, a weird dragon thing built out of robotic parts that breathes fire. It really doesn't matter. As long as you're following the builder pattern, you can do that very, very easily. Moving along with creational patterns, let's look at the factory method. Now, this is different than the abstract factory that we've already talked about. The factory method defines an interface for creating an object, but lets the subclass decide what to actually do. And it's actually pretty simple. For example, you have an injection mold, you want to inject, but you're going to let the subclass determine, is it a rubber ducky or a toy car? It's different than the abstract factory we covered. The abstract factory provides an interface for creating families of related or dependent objects. So this is way, way different. Now, we're going to change things up. Slip in here. I've got an interface called iDelay, and we're going to kind of break some rules, if you will. We're going to kind of merge this a little bit and add our own little style to it, and we're going to do away with the whole concept of subclassing and just wrap this right into a function just to show how dead simple this can be. So I think sometimes people overcomplicate this, and maybe I am in a little bit as well. So anyways, we've got the iDelay interface, which just delays, is complete, and then we have a deconstructor. This will annoy people because they want that to equal 0. Now we've got a long delay, which is just a queue object, nothing in it. We haven't done it yet. Same thing with the short delay. And then we've just got their implementation files. All right, our main, there's absolutely nothing in there. So a little bit of copy and paste action. Bang. Queue object, queue timer, queue debug, queue shared pointer, queue text stream. Interfaces iDelay. Long delay, short delay, and then we have two queue shared pointers. One is an iDelay, one is a timer. Whew. All right, so that is a lot. Let's go in here and start working this. So first things first, let's go into our short delay and let's figure this thing out. So going to have queue object and we're going to implement this iDelay interface. Let's go ahead and right click. Move that up so we can see what we're doing. Bang. And then let's go ahead add in our variable here. So very, very simple little class, just implements that interface. We have a delay is complete. We have a private variable. I'm going to flip over here and let's go ahead and say, we want to put in QThread in here as well. Got a little sidetracked when I was thinking. All right, now let's move forward. So first things first, we're going to set this to false. And our short delay, we're going to say QThread, current thread, and this is going to be blocking. So it's just going to take our current thread and just put it to sleep. And this is meant for very, very short delays because this is blocking. And then probably help if I put the equal sign there. Grab this. Again, this class is just completely dead simple. Really all we're doing is just demonstrating this. Now let's flip over to long delay. And long delay, got a little tongue-tied there. Queue object, queue timer, interfaces, and you know what? I'm not sure if we want to mess around with threads. We're just going to stick with the timer here. Let's go ahead and go public. We're going to implement the iDelay interface. All right, and then for our private, we're going to add a couple things here. We're going to add in a private slot called timeout for our queue timer, and then we've got our internal timer and our internal bool. Let's go ahead and add that definition in there. And then we are just going to say incomplete false, and then I'm not going to spend a lot of time doing this. Then we're going to say timer single shot, one of the most useful things in the world. And we're going to say long delay, timeout. So what does that really do in case you've never worked with the Q timer single shot? Really all it does is it says wait a certain number of milliseconds on a separate thread and then take a slot and call it. So we're saying this timeout, which is going to be this guy right here. And we're going to say, so really what are we doing? Same thing, we're just not blocking the current thread. All right, so two very simple objects that do virtually the same thing in different ways. Now, what we can do next, let's take a look at this, is we're going to make some functions here. So first things first, we're going to say void timeout, and we're going to say Q info do other maybe things while we wait. Now we're going to take our iDelay pointer, this guy right here, and we're going to say if is complete, then timer stop. There we go. Timer is this guy right here, our Q shared pointer. Could have done that a billion different ways if we really felt like it, but really that's all we're doing is we're just going to do some things on this timer and wait for that iDelay to complete. Let's take a look at how are we going to actually get the delay. This is part of the actual factory method. When I say part of it, it's pretty much for this example the entirety, but you could actually put this, if you were following the design pattern to the letter of the law, inside of an object. But I'm just showing you don't really have to. And we'll say int ms, which stands for milliseconds. Help if I actually did that as an int. So all we're saying is get delay, and we're going to determine based off the amount of time what type of iDelay interface we're going to return. So if it's less than 100 milliseconds in this case, we're going to say QInfo. Man, screw that all up. We're going to return a short delay. And then we're just going to say return new short delay. Otherwise, if it's longer than 100 milliseconds, we don't want to block our application. So we're going to say return long delay, which, if you remember correctly, goes through that single shot. That way it runs on a separate thread, and we don't have to worry about locking up the execution thread or our main thread in our application here, because we are running on the main thread at this point. Whew. All right, so what we're going to do next, I've got some code off screen. I'm just going to copy paste, save some time, and we're just going to say get the time out here. So QTextStream, we're going to read the standard input. We're going to get the number of milliseconds from the user, make sure it's actually an integer, and then say OK. And we could put some other logic, like if it's too long or too short, or if it's a negative number, or whatever we wanted to do. And then I'm going to add in some additional code just to show, bang, how we would set something like this up. We're going to have our timer. We're going to set that interval to 1 second, and then we're going to connect signals and slots. We're connecting the QCore application about to quit to the timer stop. And notice it says timer data because we're connecting to that pointer. And then we're connecting the timer pointer to timeout to timeout. So it's QTimer timeout to this timeout. Really not super hard. This is where we're going to work with our actual factory. So I'm going to say int delay equal get timeout. And then we're going to say ptr and I want to reset. Did I do that wrong? Nope, I did not. Didn't like it. Oh, there it goes. IntelliSense is suddenly working. That had me super scared for a moment. We're going to get the delay, and we want the delay. So we're going to get the timeout, get the delay, and then that sounds a little confusing, so maybe we should walk through this. The get timeout is the user input, the get delay is the actual iDelay interface. So I'm not asking the user twice if that's what you're wondering. And then I'm going to say the timer, go ahead and start. And then PTR, delay, delay. And if that's super, super, super confusing, we could rename this to something like value or timeout or whatever we wanted to do. Maybe that'd be a little clearer. I try to think in terms of somebody who English is like a second or even third language, how that could be a little confusing. Let's give it a build. Let's give it a run and see what happens. So enter number of milliseconds to delay. I want to delay 300 milliseconds. Do other things while we wait, and then pop, it should return back. And of course, it never does. What did we do wrong here? Ah, yes. We made a boo-boo. We forgot. We committed the most heinous sin. We forgot to let us know that we are done. Complete. There we go. Now it should actually display up. Let's try that again. 300 milliseconds, turning long delay, and bang, complete. Now, you might be going, no, wait a minute, that wasn't 300 milliseconds. Remember, our timer right here is only going to fire once a second. So let's try that again. This time, if we say 50 milliseconds, it's still going to wait an entire second because our timer for our main thread is still waiting a second. But we could do something like this. Well, and then it's just going to wait and wait and wait, and then bang, done. So this is a very simple and highly effective design pattern. You're going to see this over and over again in different forms, and that's why I really honestly wanted to do this a little bit different than actually putting it inside of a class. Some people argue that this actually deviates so much that it's no longer the same design pattern, but it's just the factory method. And it's just a way of saying, hey, create an object, but let the subclass or the function decide which type of class to return. Let's take a look at the object pool design pattern. So what really is this? It can offer significant performance boost. Now, I kind of chuckle when I say significant performance boost because really all object pooling is creating a collection or a list of objects. And if one of those objects is free, use it. We see that in the Q thread pool. Every Qt class comes baked in with a Q thread pool at its disposal. And that's because threading is expensive. Creating and destroying a Q thread is a little bit memory intensive. So if you already have a pool of threads sitting there waiting to be used, you don't have that initial memory hit when you go to create and destroy a thread. Think of it in terms of, let's say you have a web server and you're going to have thousands and thousands and thousands and thousands of connections, but you want each connection to be threaded. Well, you can't make, let's say, hundreds of thousands of threads. Your computer just won't do it. So what you can do is reuse those threads through the QThreadPool class because you don't have hundreds of thousands of people connecting all at once. Makes it pretty simple, pretty efficient. And that's really what an object pool does. So they have a pretty beefy description here in SourceMaking. Go ahead and read that if you're so inclined. We're going to deviate from their example altogether. And here we go. So what are we doing? Object pools. We're reusing objects. Can save resources and make things a bit faster. Notice I said a bit, they said significantly. The reason being, it really depends on your situation and how beefy the class you're creating and destroying really is. For most classes, it's going to be insignificant because most classes are pretty small. For large, complex classes, or if you're dealing with some sort of slow I/O device, it could be significant. All right, let's take a look. So I have some interfaces. I have our iPool. This is the actual object pool. It has acquire and release, and it's working with an iPool item, which is the other interface. So acquire will get a pool item, and release will release that back in. So think of this like fishing. You're going to catch a fish, and then you're going to release it back into the water so someone else can catch it. All right, now iPool item. This is the individual item, or the worker, if you will. So we can acquire it and we can reset it. All right, now we have our myPool and myPool item. So let's work with the myPool item first. I'm gonna copy and paste a bit of stuff here. Bang. So first things first, let's go ahead and implement this iPool item interface. Right click, refactor, insert virtual function of base classes, and bang, a set and acquired. Now let's go ahead and add. I'm going to try and save as much time as I can here. Right click, and we're going to create a setter there. So we have our set acquired. And then let's go ahead and I'm going to move this up here just so we don't confuse the two. And I'm just going to make a simple test function. Now let's take some code off the screen because this is not doing really anything super significant. The constructor, we're setting acquire defaults. The reset, we're saying false. Reset is when we're putting the fish back into the pond. Acquired is when we're fishing and we pull it back out. So we're going to acquire a worker and then say you're done working, go back to what you were doing. Set acquired, it is what it says it does. It sets the acquired. It's just a setter. And then test is just some little test function. Not 100% certain if we're going to use that or do something else yet. All right. Super, super simple. Didn't want to spend a lot of time on it. Let's go ahead and take a look at our pool. We're going to use the iPool and the iPool item interfaces and the myPool item header. Let's go ahead and implement our pool. Right click, refactor. We spend a lot of time doing this. We're going to implement acquire and release. Very, very simple. We're also going to use a queue list of myPool item pointers in m_list. Very, very simple. Now, because we're working with pointers, we got a bit of memory management, so I'm going to say myPool deconstructor. And let's flip over to the source. I'm going to save a bit of time here. Some people love it when I copy and paste, some people hate it, but it is a huge time saver and it's code that admittedly is not super hard. So constructor is blank, deconstructor, because we have a list of pointers, we're going to queue delete all to free up all that memory. And redundant, that's not even a word, redundant if we set at the parent on each item. And then we're just going to clear the list so we don't have dangling pointers, which we're deconstructing, so we really wouldn't worry about that. Now, acquire and release. This is the interesting bit. This is part of the design pattern itself. So acquire, think of this like fishing. You're going to say, okay, go ahead, go into our object pool and find something where it has not been acquired, meaning something else isn't using it. Go ahead, set it to true, and return it, meaning we're now going to use this item. If we get to this point, that means everything else is in use. And this is a design decision. You may want to put a limit. You may want to put that request into some kind of queue like the queue thread pool does. You send it a queue runnable. What we're going to do is we're just going to say make a new item, set it to acquired, add it to our list, and then return the item. So we can grow dynamically as we need to. Not really a healthy design choice, but it serves its purpose. Now release, we're just going to take that item and say if there's no item return, but otherwise we're going to reset it or release it back into the pool so other items can go through and acquire it. Whew. A lot of explaining, but it's actually very simple. You're either going to acquire or release the item. Not super hard. All right, let's go into our main. Let's give it a good build, make sure we didn't goof anything up. And from here, it's pretty straightforward. We have our iPool item, we have our myPool, and our myPool item. And we could do this, admittedly, a million different ways. So let's go ahead and make a function called useItems. I'm going to say myPool. And like I said, we could do this any which way you want. It really doesn't matter at the end of the day. Some people are sticklers for pointers, some people hate pointers. It just depends on what you're doing and how you want to do it. So what we're going to do here is we are going to, you guessed it, grabbing X number of items. So we're going to grab some items from our pool. And I'm going to say Q list, and let's go my pool item. And that's going to be a pointer. Let's call this items. And then we're going to say for int I equals 0. I is less than the max. We're going to go ahead and say I increment, and you guessed it, we are just simply going to start grabbing items out of our pool here. So I'm going to say my pool item. And we can do static cast, we could do QObject cast, whatever you wanted to do. Just go ahead and cast this, and we're going to say pool acquire. Actually, we couldn't do a QObject cast because it's not officially a QObject, this little guy right here. All right, back in our main. So we're going to static cast that out. We're going to acquire that item. Now that we have it, I'm going to just simply say items, append, and I'm just going to add that in there. Now let's go ahead and use those items. So I'm going to say for each, and I'm going to say my pool item in, you guessed it, items. You can see how this just becomes very, very simple at this point. And let's go ahead and just use that internal test function that we did. And I'm going to say test. From there, because we're done working with them, we should actually release them. And I'm going to say, actually, pool release. Got that all backwards. Wow. How did I make that mistake? There we go. We're going to release that item. I release you back into the ocean. Go forth and create more items. Now, we're just going to work with our pool. So I'm going to say my pool. Let's just call this pool. And we're going to use items. Let's go ahead and hand it our pool. And let's say we want to use 5 items. We could, if we really wanted to, grab a single item here. So let's grab this. So I'm going to say my pool item equal static cast my pool item pointer, and we're going to pool acquire. So we're going to acquire and use 5, and then we're going to acquire 1 more, and we're just going to play around with this thing. I'm going to use items 3. Whoops, get rid of that. And then I'm going to release, and I'm just playing around. We're really not doing anything super important. Just showing the overall pattern, how you acquire and then you turn around and release. Acquire and release. That's really all you need to know about this pattern. People like to make this super, super complex. It's not. It's easy. So let's run this. Sure enough, you can see we are acquiring, we're running our test, and we'll go ahead and resetting these things. Very simple, very easy to use. So where does this really differ? And here's the kind of the catch here. I mentioned at the very beginning QThreadPool, because you notice that QThreadPool, while it is an object pool and does follow the object pool design pattern, differs drastically from not just SourceMaking's example, but the example I just showed you. So what does this really mean? It means that A design pattern is a rough framework or an idea. It's not a set in stone rule. You can do this however you want. They do it a certain way, I do it a certain way, and Qt did it some other way. So what Qt does with Qt thread pool is you hand it a Q runnable, and it puts that runnable in a queue or a list, and then when it has available threads to get to it, it'll process it, run it, and automatically remove it out. So it actually does the reset for us. We don't have to worry about it. The major takeaway here is that you have a reusable pool of objects, you acquire them, and you release them. Let's talk about the prototype design pattern. It's one of the creational patterns, and it's actually pretty simple. What is a prototype? A prototype is not your finished product, but close to it. It gives you a very good idea of what you're going to get. So the prototype design pattern specifies the kinds of objects to create and create objects by copying this prototype. So basically you have an object, you copy it, and then modify it and hand it back. Now you should note the new operator is considered harmful. This is where it gets a little weird. So you create a new object, but the new operator is harmful. Well, then how do you create a new object? We're going to take a look at this. They've got a really good example on source making. I know I keep pointing back to this, but it's probably, I'm just going to say it, one of the best resources out there for the classical design patterns. All right, for our example, remember, Q objects don't like to be copied. Spray paint it on your wall, tattoo it on the back of your hand, whatever you need to do. Just remember, Q objects don't like to be copied. So this will fail. For example, we're just saying bang, bang. So this is one of the hurdles we have with this particular design pattern is the new operator is harmful, but we really have very few ways around it. So let's just toggle comment on that, get rid of that guy. Got some already written up code here. For example, we've got our iClonable interface because part of this pattern is to be able to clone or copy that. We could have called this iCopyable. And then we just have a simple class here. Now I've put some getters and setters in here just so you don't have to waste time watching me put all this in here. So we've got first name, last name, age with the getters and setters for each, and then a display function. And if we look in here, you can see there's not a whole lot of mystery, and display just spits it out. So let's jump over here and let's actually implement this interface. And let's right click, refactor, insert virtual function of base class, and we're going to implement the iClonable clone. If you're from the .NET world, that's going to look really, really familiar. Now, in clone, this is where things get a little bit different than what you're going to read on source making. So I'm going to say my class, and I want to make this a pointer. And the first thing we're going to do is new. Now remember, the new operator is considered harmful. This is where it takes a little bit of explaining. We have to create a new object, but when we're working with our prototype, we want to call clone and let clone handle the new portion. If that doesn't make any sense, it will here in just a second. So we're going to create a new instance of my class, and we're going to manage the memory by setting the parent. Then we're going to use this as our prototype. So I'm going to say my class set age, and I want age, and then my class set the first name, and we can get rid of this if we really don't want it in there. And then my class. And you can do this for pretty much any type of property you want. Just keep drilling on down. The whole intent here is that we are going to fill in as much of this object from our prototype as we can, and then simply return it. And because a QObject's not copyable, we have to return a pointer. Pretty simple. All right, so let's jump into our main. And we've already got the my class included. Let's give it a good build, make sure we don't have any little gremlins. And let's say my class, let's call this Brian. I'm going to set the age. Let's set this to 45. Set the first name to Brian. And then set this to your last name, whatever your last name may be. All right, so this effectively becomes our prototype. That's what I meant by it. It would be very, very clear what we're doing here. So now that we have our prototype, you guessed it, we're going to say my class and we're going to QObject cast, and let's go ahead and my class there we go. Super simple. All we're doing is we're saying iClonable. It's going to return a pointer to a QObject. We are going to grab that. Voila. Grab that prototype. And then cast it into something we can actually use. And then I'm going to say set the first name to Heather. And then set the age to 28. And we can do the same thing with, say, Tammy. And let's set her to 49 years old. So let's grab this and fix that up. Super simple. So basically you're creating your prototype and then you're just cloning that prototype into a new usable object. And then from there, you can do whatever you want to do with it. So we can actually display our prototype and our working versions. When I say working versions, these are just working objects here. And Tammy. In case you're wondering, yes, each one of these has clone in it, so we could actually modify, say, Heather, and then use Heather as a prototype for something else, and so on and so on. And it can just be infinite if you want it to be just that complex. So the main takeaway from the prototype design pattern here is that you create an object, you clone that object. Notice how these have the last name of Karen's, even though we didn't set it. And it seems overly simple. But you have to remember, when this design pattern was created, this was called groundbreaking. I know, seems a little rudimentary, but this is a huge time saver. If you have some type of complex object, you would just simply clone it. Let's talk about the singleton design pattern. So this has kind of been phased out and something better's come up, and we're going to talk about that. So what is a singleton? Well, ensures a class has only one instance and provide a global point of access to it. Okay, sounds great in theory. Now how do you actually implement it? And there's tons of ways of doing a singleton design pattern. Most of them, and I'm guilty of this myself, most of those implementations are horribly wrong. Why? Think of it in terms of threading. You have one instance, global point of access, and all these threads are going to come smashing into this instance and do things with it. Well, threads have their own problems. You're going to have deadlocks, race conditions, concurrency issues, and so on and so forth, and we can sit here all day and talk about it. So singleton's been kind of phased out, but definitely feel free to read up on it. There's some great examples, and singleton for other languages that are not, I want to say, as in-depth or as powerful as C++ really don't have the same issues that C++ has. So for C++, we're going to use the C++ 11 magic static. And I cannot take credit for this. This is Mark Gregory's class, and it is the Singleton class, and I think it's on, am I saying this right? nuancesoft.com. I'm going to put a link to their blog here. This thing is just dead simple. I mean, it's straightforward, and we're going to run it and use it. So we're going to change it around a little bit, as you would expect. So what are we talking about? A singleton pattern or a C++ magic static. Basic premise here is only one instance of the class. Why? Sometimes you want to really limit how many instances you have. So for example, you wanted like a global timer or something like that. Now think of it like a logger. You wanted to be able to write to a log, but you have 15 threads. Well, obviously you can't open the file in write mode 15 times. You'll get locks and race conditions and things like that. We're going to dial it down very, very simply, make it very simple to understand. We just have a simple little Q object, nothing special in here whatsoever, just created, destroyed, and then displays a message. And we're going to use this singleton class. Now, where's the magic? It's right here. Static T get instance. So it's a templated class, and we're saying get instance T static. What does that really mean? Static means there's only one instance of this, so it's just going to return that instance. It's incredibly powerful. So we have a constructor, a deconstructor, and then we've got a bunch of operators that are removed. This is where the other part of the magic comes in. We make sure that we can't accidentally goof this up. When in doubt, leave those alone. All right, let's jump in here. We're going to make two functions. Scope test, and probably help if I actually made that a function. And let's call this void loop test. So what do we really have here? 3 different scopes. So, let's go down here and let's call these. We're going to say scope test, and then I'm going to say loop test, and let's go to scope test first. I'm going to say singleton, and we're going to give it the my class because this is templated, remember. We're going to get instance, and notice how this is going to return reference to the my class instance, and I'm going to just say set object name. And let's call this I need like a really, really strong name, like Godzilla. I don't know. I struggled coming up with names. Anyways, so we can take this global instance here, and we can say display from scope test. And we can actually just take this let's go starting loop. My horrible spelling mistakes. I get too excited and then I type too fast and then everything stops working. So let's say finished loop, and then let's just do something really stupid like for int I equals 0, I is less than 10. Let's go ahead and increment I. I mean, just something ridiculously mind-numbingly stupid. Just to show that it's working. And because I just feel like it, we're going to actually grab this. And I'm going to say hello from main. And let's go ahead and go QInfo just to show that we can actually work with the actual class, not just some weird C++ thing. I'm going to get that object name back that we set in an entirely different scope right up here. This is incredibly cool. Save and run. Sure enough, we have created my class and we set the name to Godzilla, and it's from scope test, starting and finishing a loop, and then hello from main, and there is only one Godzilla. So my nickname for C++ Magic Statics is, of course, Godzilla, because there's one and only one. This is extremely cool and extremely powerful. And unlike the singleton design pattern that we've talked about over here, this does not have any of the baked in issues with threading because it's going to return one and only one and a static. Voila. Now, comes with the disclaimer that just because it's a magic static doesn't mean it's purely thread safe. If you start doing things like manipulating a value or working with I/O or anything like that, you may have some threading issues. So you'll have to work with that appropriately based off your specific situation.